In this lesson we are looking at partial fractions for the Pure 3 course, and we're basically doing a reverse of adding and subtracting fractions. I'll get to that in a second. I'm just writing down like methods that we're doing today. You can use binomial expansion, you can equate terms with simultaneous equations, you can use integration as well. That'll be part of this course. But today we're just going to look at how this actually works. So you have linear, quadratic and cubic and beyond kinds of denominators. So looking at a proper fraction, we will split up the fraction into a sum. So we have a and b in this case, and there'll be more than a and b in further examples. So just drawing this out now, for an example on the right hand side, to see how it works. So we have a over the first 2x minus 1, and b over x plus 1. So just based on that example that you can see on the left hand side, a non-repeating linear factors on the denominator. So we'll just basically write out now our numerator. So it's a times x plus 1, multiply across, and b times 2x minus 1 is equal to 7 minus 2x, which is our original numerator. And then from there on we substitute in values for x. So 7 minus 2 times a half. And you'll do that 2 to 3 times, depending on the difficulty of the question, if you have two sums like in this question. So there we have a is equal to 4. And again, do the same for the next one, like we have x plus 1 equals 0, so x was equal to minus 1. And you'll see that it cancels out one of the terms, one of the factors. So that's actually what's happening here, is we're splitting the fraction, multiplying by the denominator, substituting in values, and then you can rewrite the original as a partial fraction or partial fractions. We'll just do that now. So a is 4, b is minus 3. Be careful with that minus 3 as well. So I've just replaced it there in the middle. And that's our first one, non-repeating linear factors. When you have repeating linear factors, you just want to be careful, because you have what you might see as 2 factors, but there's actually 3 factors. So if you see 3 factors and there's a square on one of them, there's actually going to be 4. So just be very careful. In this case, there's like an extra x plus 2. We'll just jump on now to quadratic factors. I'll be doing examples of these as we go along. So quadratic factors, when we use a quadratic within the bracket, there's a specific way of doing it here. So take note of what I have highlighted there, bx plus c. So a lot of this is kind of similar, but you will have to kind of learn this in isolation and just practice a few of them yourself. So again, a plus bx plus c with our regular denominators that we have for this question. Just be careful with this now when you're looking at it. So 2 minus x and 1 plus x squared. So it's pretty much like the last one. So there's a little difference. There's lots of little differences that you need to be taken note of. We're doing the same thing really a lot of the time once you get used to it. So again, writing out the numerators here, multiply across a times 1 plus x squared and bx plus c times 2 minus x. Same as you would with a regular fraction even. Again, try and make it equal to one of those terms. So 1 plus x and 2 minus x. So we made x equal to 2 there. It's equal to 4. And when we're not really sure where we have a term or not, because of the fact that we have more than one unknown value there in terms of the b and c terms there, just plug in 0. So if you're not sure, you cannot find something, if you're factorizing or you're trying to figure it out, you should just maybe just try x equals 0 to see if you can find an unknown, and that helps in this particular part here. And again, you could try x equals 1 or minus 1 as well. So c is equal to 1. And then for the last part, x equals 1. So 6 plus 7 times 1 is 13. Just multiply them out yourself as you know. A disappears, so we have b is equal to 4. 13 minus 9 is 4. And again, write that all out again. So you'll have a plus bx plus c. I'll do it on the left-hand side here in the green, because they won't fit. And that'll just show you then the answer and how you will rewrite it at the end. So always write the original at the end as partial fractions. I'll lasso that across. There we go. Those were our quadratic factors. Lastly, I have just a little combined version. We're not going to do that, but just a combined little version of how this could turn out with A, B, C, D, and E. So a very expanded question if it turns up. With improper fractions, the degree, the highest power of the numerator, will be greater or equal to the degree of the denominator. So I'm going to highlight aspects in this part, in this section of this video. And just looking at an example there, we have 4x to the power of 3. And on the denominator, we have 2x times x, which is 2x cubed. So 4x over 3 divided by 2x over 3 is equal to 2. And so you'll see that's why the part A doesn't have a fraction. So there'll be questions like this, and just check that, whether it's non-repeating linear factors, or as we see in a few moments, quadratic or whatever. That is something that you need to look at. So again, let's just check it here. We have x squared on top, and then we've x times x squared, which is x cubed. So this is just me demonstrating that that's a proper fraction. However, if it had been x over 3 on top, you'd see that it would just be a on its own. So in this case, I'm just trying to demonstrate that x plus 2 all over x plus 2 is 1. And that when you see these kinds of aspects, just check that initially, just to make sure you won't be confused by whether it's proper or improper in terms of the fraction. So repeated linear factors there. Quadratic factors, again, you can see it's like a plus b plus c, x plus d. But again, why is a on its own? Well, we've 8x cubed, and then we have 2x times x squared, which is 2x cubed. So of course, a is equal to 4. So if you come across a, for instance, as a whole number, you will recognize that this was an aspect of that. And we will be doing a question next that has an element of this in it. Looking now at our first of 3 exam questions, I'm going to write out what we need. We have a quadratic, so there's not 2 factors, there are 3. There's an extra one. There's an extra x plus 2. So a all over 3x minus 2, x plus 2, and then the quadratic x plus 2 squared. And why is that put in there? Because we won't be able to cancel out. If we made x equal to minus 2, we just wouldn't be able to get a value for b and c, if you notice with that, if there wasn't the square on it. And so when we get b here, for instance, we'll multiply b times both of them other terms that are not under it. So it might take a little bit of extra practice to look at that just to check it. Then we sub in or let x equal minus 2. So x plus 2, so minus 2 plus 2, so a gets cancelled out here, and so does b, and so we can find c now with this. So c is equal to minus 4. Let x equal to another value, 2 over 3 in this case. So we can put in a there. We have 3x minus 2 in both the other unknowns, so we cannot use them. So we find a here. And now a new thing perhaps, but let me just get that. Yeah, a is equal to half. Now we're going to equate x squared terms here. I'm sure that's what your book would say. So what that means is we're going to get x squared from wherever it is in this. So we know there's an 8x squared, it's very obvious. So that means it has that. So 8 is equal to. Now, just look at A, B, C in the second line, in my first line that I've done, not in the actual sum. So A does have a square. But B has a 3x squared, 3x times x. And C does not have any square, any coefficient like that. So from there we can find B. So B is equal to 3 over 2. Maybe I'll write that out just a little bit more. So 8x squared was equal to ax squared, x squared in that, plus the 3bx squared in that second set of terms there. And then, of course, at the very end, after splitting it, multiplying it out, substituting, write the original as partial fractions. Be careful of your minus and positive values there. You don't want to mess up that at the very end. And there we have it. Plus C. Be careful. Minus 4. Okay, that's our first example, first exam question. Solid one with a quadratic as well, and we had to equate the x squared terms. All right, here's a question. Now, this was given already, so the two left and right hand side are both given in the question. So where do we start? Well, we just start with our numerator. So 6x squared minus 1 is equal to a. Now a is times what? So just think, it doesn't have those other factors, so we multiply both of them by a. Plus b times the one that it does not have. So b is times x minus, or x plus 1. And c times 2x minus 3. And then we're going to put in values. So x can be equal to minus 1. X plus 1 equals 0. X is equal to minus 1. Plug it in. We'll get a and b gets cancelled out. So c. And then c is equal to minus 1. And again, for the second one, we have 2x minus 3 is equal to 0. So x is equal to 3 over 2. And we have no a and no c, so b in this case doesn't get cancelled out. So b is equal to 5. And again, just like the previous question, we will equate x squared terms here. So we have it with the original numerator, 6x squared, so 6. And a appears to be the only one. So a has an x times x, which would be square, and it's 2 times that. So a constant of 2 times the variable of x times x, which is 2a. So a is equal to 3, and that's the final answer for that one. Again, we split the fraction into a sum, we wrote out the numerator, we multiplied out that bit, we substituted any values in, we equated the terms, the coefficients, and now we're going to write the original as a partial fraction. So you can always check your answer as well by subbing in the value of x, a small value usually, hopefully. You can sub in the value on the left and right side to see if it's equal. So that works. That was the second exam question we had, and we're going to do one more. So once again, express this as partial fractions. We have a cube, we have a cubic element, and we also have quadratics. So we're going to have to do something a little bit different here. So 3x cubed minus x squared, we're going to factor out the x, or x squared. In this case, x squared times 3x minus 1, and now we can use this. So we'll get our ABCs, so to speak. So a times 3x minus 1. And the other ones will have an x. Or again, you have not 2 terms, but our factors, not 2 factors, but 3. So it'll be x squared in the end. Okay, from there we can multiply across. So ax squared would be our first one. B would be 3x minus 1 and x squared, if you think about the way we've been doing it. Will it be x squared? It's just the x. And c will be just times 3x minus 1, because it already has x in its denominator. So set the numerators equal, which you've just done, And you can sub in to make some kind of values terms disappear again as usual. So x is equal to 0, we'll get a nice value for c there. C is minus 1. Again, 3x minus 1 is equal to 0, so x is equal to 1/3. Plug that in as well. It doesn't go into b and c, so just a. So 1/9 a is equal to 4/9. And we get the value for a there. So a is equal to 4. And then when you're doing this, sometimes you're not really sure. As I said already, in a different question, you can plug in x equals 0, which is what we did. But we have kind of a and c that would disappear or not at the same time. So we want to just find a value. So just plug in 1. X equals 1 or x equals minus 1 perhaps sometimes. But just plug in a simple value to see how that works. So a times 1 squared plus, again, the b you can put in yourself there. 3x minus 1 is like 2, so 2b. Plus then, again, c is the same, so 2c is equal to the 10 that we have there. So 16 times 1 minus 7 plus 1. And we know already that a and c were given there, so b is equal to 4. And then at the end of that, rewrite it, express it, as it says, as partial fractions. There were a few insights into partial fractions in Pure 3 A-level mathematics.